I'm going to review the concepts from Chapter 7 that you're going to see on your quiz. So Chapter 7 talked about sampling distributions. So we want to review what a sampling distribution is. And it is all the possible values of the statistic and how often it takes these values. So remember, in a sampling distribution, because we are going to do it a lot of times, the mean of the sampling distribution ends up being the parameter, and the more you have in each sample, the less sampling variability that we're going to see. So next we want to talk about specifically when the sampling distribution of p hat is considered normal. So remember, p hat represents proportions. Okay, so you have to test two things. You have to make sure that NP is greater than or equal to 10, and n times 1 minus p is greater than or equal to 10. So remember, this is that 10% rule where you want to make sure your sample is at least 10% of the population. So next we're going to take a look at some examples. So we have the proportion of students who studied over Christmas break is 12%. If a sample of 120 students is selected, answer the following questions. So we want to talk about the shape, mean, and standard deviation of our sampling distribution. So the first thing we need to do is make sure it's normal. So to check to see if our sampling distribution is normal, we use that formula from problem 2. So n is 120, p is our 0.12, and we want to make sure it's greater than or equal to 10, and 120 times 0.12 is 14.4, so we're good there. Now we check 120 times 1 minus p, which is going to be 0.88. We want to make sure that is also greater than or equal to 10. So 120 times 0.88 is 105.6. So we do have a normal distribution. Okay, next we want to look at the mean. So remember, the mean is going to represent the parameter, and we're talking about a proportion, so it's p hat, and it's going to be 0.12. Okay. Now we want to calculate the standard deviation. So remember, when we calculate the standard deviation, I guess I should use the correct notation. So it's mu p hat, it's going to be 0.12. Okay. So our standard deviation, remember the formula for the standard deviation is the square root of p, so 0.12, times 1 minus p, which is 0.88, all over n, which is 120. So 0.12 times 0.88 is 0.1056, divide by 120, and then we take the square root, and we get 0.03. It's actually 0.02966, which we typically do 2 decimal places for standard deviation. We end up with 0.03. So now we're going to use what we did in number 3 to find the probability that a randomly selected sample size of 120 is greater than 15%. So I'm going to draw our curve because it's normal. So we have our 0.12, and 0.15 is above that, and it is asking for greater, so we want greater, which means we're going to find the area below. So first we're going to calculate our z-score. So z equals 0.15 minus 0.12 over 0.03, which is going to be 1. Okay, so now is where we use normal CDF on our calculator. We're going to put our upper bound to be 1, our mean and standard deviation are going to be 0, and we're going to get an area of 0.8413. But remember, anytime it says greater, we have to do 1 minus our area below. So we're going to do 1 minus 0.8413. And our probability is 0.1587. Next, we want to find the probability that a randomly selected sample size of 120 is within 1.5% of the actual proportion. So I'm going to draw the normal curve. So 0.12. So if we want to be within 1.5% of the actual proportion, we do 0.12 plus 0.015, and that gives us 0.135. So that's the one above. And then we're going to do 0.12 minus 0.015, and that's going to give us 0.105. So we have two z-scores that we need to calculate. And if we want to be within the 1.5%, we're going to find the area between the two z-scores. So we're going to do below both of them. So we're going to get two areas and subtract. So our first z-score, I'm going to do the 0.135 minus 0.12 over 0.03, which we already know the numerator should give us 0.015 because we're within 1.5%. Then we divide by 0.03, and we're going to get 0.5. And our second z-score is 0.105 minus 0.12 over 0.03, which will get negative 0.015 in the numerator, which gives us negative 0.5. So if we calculate both of the areas below these values, so we go and put our upper bound as 0.5, we get 0.6915, and then we do it again with our negative 0.5. We get 0.3085, and because we want the area between, we're now going to subtract these. So 0.6915 minus 0.3085. And we're going to get 0.383. Your other option is to use normal CDF with the lower bound being negative 0.5 and the upper bound being 0.5. And it's going to give you the already subtracted area, which is 0.3829, which is rounded to also 0.383. Next, we're going to take a look at an example with means. So we know the average number of hours students studied over Christmas break is 2.25 hours with a standard deviation of 3 hours. If a sample of 120 students is selected, answer the following questions. So we're going to start off with the same question: what is the shape, mean, and standard deviation? And explain our answer. And we're going to explain our answer with work here, not with like an explanation. So first we start with the shape. So we can assume a sampling distribution for a mean is normal if the sample size n is greater than or equal to 30. So is 120 greater than or equal to 30? And it is. So we have a normal shape, normal distribution. Next, we're going to look at the mean. So again, sampling distributions, the mean of our statistic ends up being the mean of our population. So in this case, that's 2.25 hours. And our standard deviation is calculated by doing the standard deviation of the population, which is 3, divided by the square root of n, which in this case is the square root of 120. So So we do 3 divided by the square root of 120, and we're going to get 0.27. So we can now use the mean and standard deviation to find some probabilities. So we want the probability that a randomly selected sample size of 120 has a mean time studying greater than 2.5 hours. So I'm going to draw the distribution. So our mean is 2.25, and 2.5 is above that. And we want the area above. So we're going to calculate our z-score. So we have 2.5 minus 2.25 divided by 0.27. And we're going to get 0.93. So when we go into normal CDF, we use our lower bound as the -1e99, our upper bound as the 0.93, and we get an area of 0.8238. And again, it says we want greater than, so we have to do 1 minus 0.8238. And we get a probability of 0.1762. Number 8, we want to find the probability that a randomly selected sample size of 120 is within 1 hour of the actual average. So I'm going to start off by drawing the distribution. So we have 2.25. 1 hour above that is going to be 3.25, and 1 hour below is going to be 1.25. And we want within, so we want the area between the two values, which means we're going to calculate 2 z-scores and subtract. So our first z-score, I'm going to do the area above, so 3.25 minus 2.25 over our standard deviation of 0.27. So now we're within 1 hour, so the numerator is going to be 1. So that's going to give us a z-score of 3.7. Our second z-score, we want an hour below, so that's 1.25 minus 2.25 over 0.27, which we're 1 hour below, so when your numerator is -1, we divide it by 0.27, and we get -3.7. So if we use our normal CDF with our 2 upper bounds, our first area ends up being 0.9999, and our second area with the upper bound being the -3.7 is 0.0001. So we want within, so we're going to subtract these, so 0.9999 minus 0.0001. And we're going to get an area of 0.9998. Okay. Remember, we do have the other option of using normal CDF with the lower bound being -3.7 and the upper bound being the +3.7. And it's going to give us the area of 0.9998 without doing the subtraction. So you have 2 options. Right? Let me know if you have any questions about anything from Chapter 7 before you take the quiz.